and he explained me how to solve Sudoku and rules of that. And so my congratulations to him will be related to partially to this meeting. Sabir. No, after that I can take another chalk maybe. But who knows, well, Russian could translate to Spanish or to English. Судока пустяковое дело. Английский тоже ерунда. Это я имею в виду для Сабира. So if somebody will not understand something in English of my English, please ask. Бескомпромиссный. Он и смелый. Ну и всем известна статья его про истину. Истец он, истины всегда. Расписан день его всецело. Всецело. Сергей is left. Уроки. Известно, что Sabir is good teacher. Уроки. A good friend. We also had our meetings in terms and other places. И суета, которая нам очень часто нам как бы занимает большую часть нашего времени. So good wishes and for the future. And I will speak maybe about things which are not in context of the mainstream of the conference, but nevertheless, first part of the talk will be really related partially to singularity theory. And I don't know, sorry, because I just arrived yesterday. I was not participating in meeting even online, so sorry. Maybe that is in some ambient here it's presented, and so due to that presented in the mind of everybody. The first, really, that is a classical problem, optimization of cyclic processes. Even we optimize our cycles in the life. During the year we have teaching, we have vocation, we have something else, and very often we have some standard and repeated from time to time these steps, and so we get some cyclic process in our life. We know a lot of agricultural cycles, aquacultural cycles, and for example cycles on the plant when we have financial cycle during the year in some company, and how to use better money, etc. And in Arnold seminar topics, this type of problems appeared, I think that 40 years ago, in 1985, and Arnold discussed the increasing of productivity of plant, and that is well-known problem in the economy, that when you have say some production, and you have some loading like control, and there is something minimum loading, and maximum loading of plant, then the characteristic of productivity is sigmoid type, something like that. And generally, nevertheless, plant works on this level or on this level. And so in general, we have we can provide only some medium type of the loading. But if you always will take such type of the loading during all time, we get this output. But sometimes plant works in different state from one to another. And so Arnold draws this picture and says that if we stay appropriate time here, work in this regime or in this mode and in this mode, we can get something on convex hull and productivity will be higher. So that was the main issue or the main result of on the paper published, and something more in the Siberian Mathematical Journal in Arnold. And after that, but nobody from the seminar takes this topic for consideration. And then already in this century or in 2000 and 2002, oh, so sorry, I should write in this way. In 2000 and 2002, Arnold published 2 papers more related to the optimal control of cyclic process. And the main subject that is the paper in the translation of 2002, and he introduced firstly the control system for the cycle, for the description of the motion along the cycle, where of XU. And secondly, he introduced the density along the cycle. So it considered density which does not depend on the point of time. So it's stationary. Stationary density could really appears in application. For example, if we consider the grassland or pasture and annual use of them, then each time when we became use again, for example, grassland, so it's for example here in Russia more or less in May and up to October, and we go back already again to the use the next year, and so we could consider that the density is really constant. And the functionals that was considered was this one, where x of t is admissible motion, and consider limit upper or just limit that go to infinity, but to avoid non-existence of limit, we take upper limit, but also you could consider the minimum, the lower limit, in order to like the production which you guarantee for your life during all forthcoming generation of our population. And so you can see this we have written these formulas. The main result of Arnold in this paper was the following one, that if we consider this density, so that is the density f of x, at this here with x, on the cycle x is periodic, so there could be, we could point, for example, to pi in some place and consider after that periodicity. That if in order the optimal motion in such situation Arnold really considered f of x as far as I remember, sine of x, and he proved that there exists level C. Here is the green level on this picture. That if the density less than this level C, we should go with faster velocity. But if this density is bigger than C, we should go with slow velocity. That means that his example was very simple. When you go to collect some mushrooms from the forest, when in the places where you know that here we have high density of the mushrooms, we go slowly to collect them. But if you know that here we have no any mushrooms, we go faster in order to get another place where we have a lot of mushrooms. And so that was the optimization. In generally, also for such type of the situation, he draws that the respective, we have, for example, two curves. One of them, for example, productivity, and other was period of the motion. And this curve looks like this one. So with minimal velocity, we have some maximum period. With maximal velocity, we have minimum period. And the best outcome is average in our situation will be this point, which is the first tangency of the line which fall on our graph. And so we have select this period and this respective optimal motion. That is T curve, T of level C, and outcome, how it's profit or benefit. Benefit is P of T, P of C. And so after that, just if we make look on the control system, so we should find minimum V of x u over u. U is from some compact, for some closed manifold or disjoint union of this manifold of maximum V of x u. Oh, and in order to apply here the singularity series, namely the maximum and minimum of family of functions, we should consider the smooth situation, and also smooth situation is in such a case provide us that we have all theorem existence of the motion, existence of the limit motion, etc. And so that was the work of the achievement of Arnold, and also in the 2002 in the paper he formulated some hypotheses. For example, that in some situation the switching between type of the motion can be stochastic, but up to now we don't observe the stochasticity in such type of the problem. So that is that I draw. So after 2002, this problem became interesting for me after this second or third work of Arnold, and I became to study it. And our first achievement was done with Helena Mena-Mates from Porta, and we proved that even if we consider the just continuous density and just continuous control system, then optimal motion always could be studied either in stationary mode, so we stay at some point and collect, or in the cyclic motion, like in the Arnold situation. I should say that in Arnold situation, there is prescribed motion along the cycle, where V is always greater than 0. We have such type cycles in the life. For example, the season cycles are prescribed. Agricultural cycles are prescribed because V is always positive in such situation. But for example, in our life, the cyclic is not prescribed. We could work and could have a rest and do nothing sometime and then continue to work or go back to the problem, etc. And we prove that when we take any control system, so V is not obligatory, how to say, is not greater than 0 or any one, continuous, then the optimal motion always can be found either to stay at stationary point or to use some cycling motion. And it's easy to show that optimal control could not be unique, could be not unique in such situation, even in Arnold situation, in some sense. And so after that, this theorem give possibility to analyze numerically some applied situation, but we never do that. That's Arnold. After that, there was some generalization done by my student Tatiana Shutkina. L is not needed. Shutkina. She replaced the objective functional for this one, which we have on the right hand side. So some coefficient was introduced. The first one, sigma, could show us that the mushrooms which we collect in the beginning could be of worse quality in the end of our cycle than the mushrooms which we collect, for example, in the end of our cycle. And the denominator beta could mean, for example, that we have experience how to collect, and so during the cycle, and so that could improve our outcome after the cycle. And so classification, the respective classification, for example, related, for example, which of when we consider parametric situation, namely, we ought also say x dot equal v of x u in some parameter, one dimensional. And so f is f of x mu, also all situation is smooth. Then, of course, singularity of the minimum velocity, singularities of the maximum velocities, and also some singularities of f. I mean that when the level c cross maximum or minimum of the f, there can appear singularities of our profit, optimal profit. So this is optimal profit p. Then these singularities were classified for some lower dimensional parameter case, but these results are published by these others, and so I will not touch. And we'll go that more or less around 2007, 2015, and let's go ahead. But in 2008, Arnold was participated in Suzdal conference and said two things in our discussion. One of them said it would be reasonably also to consider renewable resource, namely that F could have also some dynamic, for example, say density. Now I will denote P. P is small p. P is density. P, for example, A on XP, logistic type or Hershey-Hulse type. Hershey-Hulse type dynamic. And also in the talk on Suzdal 2008, I discussed the stationary solution in McKendrick equation, which that also comes from application and optimization of this stationary solution. And he said that something like that. Alyosha, you have to pay attention also to Kolmogorov-Piskunov-Petrovsky model, because it's very famous model and could provide new effects. And so after that we start to analyze some models with when the density has some dynamic. First of this problem was related to Verhulst model, but with the coefficients that depends on the state of the system. So we have again cycle S1. We have control system, which is written here, x dot x of v of xu. U is from some closed manifold or disjoint union of some ones. But now the density this is not completely recovering after one cycle, like in pastries of pastures, and have such type of the dynamic. And additionally, we introduce so-called some factor from the search theory. But here in the center, 1 minus exponent of gamma x r of x. Gamma, in some sense, characterize how it is difficult to extract or to harvest resource in this place where we are staying. And R is replaced, R on X is stay for how many times we pay attention to this point in order to collect resource. For example, the velocity of our motion through this point when we collect the mushrooms. And so harvest could be of two types, for example. This type of the harvest is impulse one, but also we could consider some feedback when we harvest each moment some portion of our density of the resource. So we have so that is formals for this situation. So the harvesting mode R is between R is between R1 and R2 and bounded by some bar R. But we have to select such type of the motions that it is bounded by some T capital, and so that is the outcome for one cycle in the formula below. We have, after that, when we collect type of the motion or collect the type of the harvesting, we could prove that we have final distribution. So the density after each consequent cycle tends to some limit, and this limit is this one in the brackets. So if we harvest too much, then we get zero. So the population, for example, which we harvest disappear. But if we harvest correctly, then the limit will be the second expression in these brackets. And B is the coefficients which we separate. You know that in this model, this coefficient is responsible for the recovering, and that this responsible for the competition in the population. So we get, finally, after that we reduce our problem to such type of variational problem. You can see that it is essentially non-linear, because firstly the P infinity depends of K of cos of A of R of X, and this is the part of fraction, part of the population which we harvest during one time. And the theorem here is there exist admissible harvesting policies. There are some effects, singularities of the optimal control, but for example, if you observe our functional under the integral, we can see that it's not concave. So we have some part which is concave, and then we have 0. And the optimal control depends from the position which we have on this picture, where we have A2 on X and where we have A1 of X. And so you can see that we have select leftmost maximizer in order to improve our efficiency of the use of our renewable resource. So in reality, the Kolmogorov-Piskunov model, which is our last studies related to the problem which stated Arnold say in 2002. That is well-known model, maybe not singularity theory, but in general studies you can see all of them were young. That is maybe only Fisher. Photo of Fisher is not of that period, a little bit later, around 1945. But all other are more or less of this period. And so you can see that they propose this model more or less independently, because publication, of course, Kolmogorov, Petrovsky, Piskunov in the West was done 1 year later, in 1938. And so, for sure, Fisher didn't know about the work of Russian mathematician. And you can see that in the Russian, the publication was done in 1937, and so that means that our team, Russian team, also didn't know also about the work of the Fisher. But it was probably on the table, like some interesting problem, because, for example, the previous talk there was discussing problems which are in the mutual interest of many participants of the conference. And that is, it was of this form, which the equation is written in the last line. And we can... This is really Petrovsky? Yeah? At all. I think that he is around 34 years old.
Yeah, because I saw him much later, but Kolmogorov, at least I can guess.
No, Piskunov is, especially Piskunov, is very difficult to find additional. No, it's very difficult to find even a photo of him. That's very strange.
But Petrovsky looked
No, if you remove the hairs, he became more looks like we saw him. Nah. And what some 20 years, or in our period, approximately 40 years to him, to this image. And so ask ChatGPT to make his older, and he give you reply. So, and we consider on the closed manifold this model. I'm not going to discuss how to generalize. That's a very simple step. But one of the steps to generalize, to make generalization of the model for the closed manifold, that it's considered as this picture, observes that this picture is clearly periodic as far as we know from the life. And there is paper by Berestitsky and Kosas that if we consider such type of the model, which in the first line, in periodic environment, and consider initial conditions which are bounded, and consider B separated from 0 by some B0, then any non-trivial, non-negative initial data will go under the evolution to the stationary, to unique attractor, really to unique attractor. And this attractor is negative, its populations disappear, and it's positive, in all places positive, if this attractor is non-zero. And it's also could be proved that convergence is uniform. Berestitsky and Kostras considered cases reasonably smooth. For example, diffusion, coefficient responsible for diffusion alpha is of class C1 plus epsilon. But now we have results proved for closed manifold for more weak, essentially weak condition, because we are going to control, and so our control will be measurable, just measurable, and so we have, at least for some coefficients, to permit to be just measurable. So type of the harvesting which we consider for this model, that is permanent harvesting. That means that we each moment we take some path u on x of our density p. That means that to the right hand side between axp minus b of xp square, we should add minus p of x u. That is permanent harvesting, so you can see. Periodic impulse harvesting. The periodic impulse harvesting is also presented in the nature. For example, when we have, say, harvesting of some salmon on Kamchatka during August. So we could consider like that is impulse harvesting. Also could be mixture. We regularly take something from the lake or from the sea for our life, and one time during the year we harvest, we make impulse harvesting, and in order to sell and get money for the life. And also we consider third type of harvesting C, when we consider the motion along some prescribed cycle. That means some like collection of the mushrooms in the forest along our traditional marshroute. And functional is the same, namely it's this one, that is the volume which we harvest by time tau, and consider the average, and consider the upper limit when tau goes to the infinity. Also, we could consider lower limit, and results will be the same. And so the main is we have again stabilization. We could show that we always have stabilization, and so if we select some type of the harvesting U and some type of the harvesting impulse harvesting, in the limit we get some function p infinity u, and here, for example, formula is for permanent harvesting. The main theorem here is that with natural assumption of the model parameters for an admissible harvesting A, B, or A plus B, the existing admissible strategy should deliver the maximum time average income in kind for an initial non-negative, non-zero resource distribution. Especially, I should underline that we consider the income in kind, because the price for different things could change. Today the price is one, tomorrow the price is another, but to count our food in this type is more interesting. No, and the result is also valid for any closed smooth manifold, non-linear for torus, and for more weak constraint of the model parameters. And that is results by Davydov, and reasonably we consider weak solutions and also etc. But biological interpretation is quite useful. So if we have some resource or population, for example, which we harvest, and if under minimal exploitation the population survive, then exists the optimal exploitation of this optimal strategy for exploitation, which provide the same volume harvesting in kind during all our coming generation. That is publication which were done related to this model. And the final part which I would like to discuss, that is non-linear or non-local. No, this problem is non-linear, non-local problem. Namely, when we consider, I know, harvesting mode C also important when we, in order to collect mushrooms. What we have here when we have some prescribed mushroom road, some prescribed road for our motion, cyclic road. Here is first factor in the integrand is from the search theory, which could characterize how it's difficult to harvest from at this point if we stay at x of t, how it is difficult to harvest or to find the resource from at this point. And F characterize how it is difficult to harvest from the position x on t at the position of y. And P is density at the point y in the time t. The problem here is the following. So if in previous cases with Kolmogorov-Piskunov and Kolmogorov-Petrovsky, Piskunov and Fisher model, the period of impulse harvesting were prescribed. Here in this situation the period is not prescribed. We again could select different type of the velocities for our cyclic road. And so we obtain in the space of fixed solution for our problem stationary solution of different period. But just by rescaling of this period, we can reduce them to one period that do not change the quality of the solution. And the solution is Hölderian, C1 plus alpha, so the derivative of Hölderian. And so, nevertheless, when we take the maximizing subsequence of optimal control and limit solution, we could select, due to Ascoli-Arcela theorem, we could select some consequence of this solution which converge, and so that gives the optimal solution for the problem in the cyclic motion. And remark related the nonlinear situation. The respective publication is 2021. And essentially nonlinear situation when we consider the same equation, L is uniformly elliptic, A depends on X and total biomass or total volume of the resource, and also the B. But it's quite natural that this dependence is monotone, namely A decrease when capital E increase and B increase when capital E increase. And so we count biomass, while we could consider also the situation when P is taken, P stays in some power in the integrand. And what we can say about this situation? We could prove here that there is no more than one stationary solution under the condition which were described on the previous page. And if under E equal to 0, so really in some sense we have no population at all, the respective Kolmogorov, Piskunov, Petrovsky and Fisher model have non-trivial solution, then exists mode of the exploitation which provide maximum harvesting in average on stationary solution. What is not proved here up to now. For example, we have no proof that we have convergency of all non-trivial solution to this stationary solution, like in the local model. And while our simulation shows that we have convergence to stationary solution, but what velocity we could not estimate. And so here we have theorem about this existence, and here we have two papers published related to this essentially non-local problem. One of them is proceeding of Steklov Institute, and another in Central European Journal of Operational Research. I think that here we have some problem which we have working with this non-local equation. First of all, comparison principle does not work, like for standard parabolic type equation. And second one, the uniqueness theorem could be also violated. So uniqueness theorem for solution. So solution could be not unique in this situation. And so I think that here we have the last slide, and my kind wishes to Sabir: be healthy, be lucky, and be successful. Да, Судаку пустяковое дело, английский тоже ерунда, бескомпромиссный он и смелый, истец он истинно всегда. Расписан день его всецело, уроки, жизнь и суета. No, I don't know, the fourth line is to the paper, related to paper of Sabir devoted to some system at Moscow State University, which estimates quality of teachers. Yeah? No, and this system called Истина in Russian, but trust in English, yeah? True. Something like that, truth in English. So, thanks a lot.
Thank you very much. Any questions?
So, to some my shame, I have to confess that I don't remember discussion at the seminar of Arnold of these problems which you mentioned and with his papers of that time. Probably I was not too much interested, so I skipped them. But I remember one problem which also seems to be connected with a sort of periodic problem and also some sort of optimization problem. But my question will be whether there is any connection of that problem with your one. And this was really a problem formulated by Arnold.
This one?
No, which I remember. I don't know all the details, I don't remember all the details, but the idea was like following. Suppose you have a sort of, so in Russian it's called baraban, so a sort of cylinder with some stones in it. So there are stones, and the cylinder has to rotate. I don't remember whether it is for splitting stones in two parts, or it is for sort of separation of different
that was not
that
was not for separation.
Just a moment, let me finish. And the idea was like that in order to optimize this regime of this baraban, of this cylinder, one should not rotate it with a constant speed, but must do something like sort of vibration, quickly, slowly. This was, I don't remember whether it was a sort of result of Arnold, or for this model, or it was a result of somebody else. But he really discussed this problem at his seminar. Do you think that there is any relation between that problem and this one?
Direct. The first things that I discussed it was really related to this situation, because as Arnold also said at the seminar, that he became interested in this problem after the letter, a message from some Siberian, как цементный завод, Crackmill, цементный завод. Who expert in English?
Cement is German word.
Cement fabric. cement fabric. On cement fabric, cement production, okay. Cement production plant, we have such type of the tubes. We have here balls, metallic strong balls. And so you load here, optimal control, how many volume you put in this cylinder. And later was to head of the Communist Party at Moscow State University. And the engineers from this Siberian cement fabric and cement plant was the following. We observed that if we make rotation stationary, we get a good portion of cement, such one. But if we take it with relax, fastly, slowly, we get better result. And so that was, Arnold exactly explained what this, more or less this situation, with faster rotation and slower rotation. Дробить камни, чтобы получить цемент. Cement mill, I don't know how, crack maybe. Grinov said that it seems to me that that give possibility for quantification.